here is this video where I will demonstrate using function notation to show equations. As you can see, I already solved problem 2. I can guide you through it, but I solved problem 12, not 12. I'm going to go through problem 11 because it's very similar to problem 12, so I figure I'll show you what I did with problem 12 after I do problem 11. Anyway, here we go. We'll start with problem 11. I have the variables written down here on this little extra sheet of paper. It's nifty because then I have more space on my other larger notebook. But this problem 11 is f of x is equal to 2x plus 1. Okay? And the first one we want to plug in is 3. F equals 3. Or f of 3. We want f of 3 equals 2 times 3 plus 1. And then easily we have 6, because 2 times 3 is 6, plus 1. Then we have 3 equals 7. Okay? The next one, we have f of negative 1. Pretty simple. Equals 2 times negative 1 plus 1. And in this situation, well, this makes it a negative number because 1 times 2 is always 2, but negative 1 times 2 makes it a negative number. So we'll say negative 2 plus 1, and over here we'll say f equals, or f of negative 1, oops, here's the equals, sorry people. And then that would mean, in this situation, f of negative 1 is equal to negative 1. It's kind of nice. Nifty right there. All right, next one. On our paper, we've got 3 over 2. So we have f of 3 over 2 equals 2 times, oh, sorry, there's a bump under this. Anyway, times 3 over 2 plus 1. Okay? And 2 times 3 over 2, 2 times 3 is 6. So we have 6 over 2 plus 1, and we have, sorry, I do this over here, but yeah. Then we have 3 plus 1, because that's what that equals, f of 3 over 2. Okay, and then we have 4. F of 3 over 2 is equal to 4. Simple enough. Oh no, I'm writing a whole lot bigger than my other one. That's okay. I'll just move over to another page. Let's see. Next variable, 4x. So we have f of 4x is equal to 2, yeah, I got that right. Okay, 2 times 4x plus 1. And then we say, sorry, we say 2 times 4x is 8x, right? Plus 1. And I don't know if I should keep writing this the whole time, but I do anyway, just to clarify that it is still f of 4x. And then this is our answer. Let me think. Okay, here we go. 4f. 4f of x is equal to, let's see. So we're doing 4f. 4f of x. This means we multiply the whole equation by 4. So pretty much what we do is we take the original equation, so we take, say, 2x plus 1, then we put a 4, I put a 4 over here. This pretty much means we're multiplying this whole part by 4. If you put it next to it, it's like, that means that you're multiplying it, I guess. Okay. So in that case, 4f of x would be equal to 4 times 2x, 4 times 2x, which is 8x once again. And 4 times 1 would be plus 4. Okay, and in this next one, we'll do f times negative x, where we go, let's see, we do 2 times negative x plus 1, which is pretty much negative 2x as far as I'm concerned. Yeah. Negative 2x plus 1. Ta-da! Okay, and then we'll do the next one. F of x. Is this the, yeah, this is x minus 4 is equal to, well, let's see, we're going to probably multiply x minus 4 by 2, see? And we say plus 1, okay? Then, in that case, you would use the distributive property. Or at least that's what they call it. It sounds very long, but it's very easy. You just multiply 2 by x, 2x, and 2 by negative 4, negative 8. And then you add the 1 at the end because that's where it goes. Okay, then we take it a little further and we say that this is 2x minus 7 because we're adding this 1 over here. Okay, and then we show it sounds the same coming from my mouth. F of x minus 4. I said that earlier, f of x minus 4. But we're doing a different one. F of x minus 4 is the same as 2, let's see, at the top it's 2x. Wow, that seems so far. Okay, 2x plus 1 minus 4. And in this case, we'll do this. We'll start with this. So we'd eventually end up with f of x minus 4 is equal to 2x minus 3, because we're subtracting a huge 4 from there. And we're almost out of paper, but you know what I'm going to do? I'm going to say f of x to the second power is equal to 2x, or 2 times x to the second power, which is true because we're just plugging this in right here. Just right here. In fact, I can even put these parentheses here, but it's not as simplified. I just assume I simplified this afterward. Anyway, minus, or not minus, excuse me, plus 1. And that is all for problem 11. Now, as you can see, what I did with 12 is I took the answers through, so this one's really easy. I just put 3 in and I get negative 9, and I put 1 in, and then multiplying 2 negatives makes a positive, so then I get 7, and then 4 times 3 is equal to 12. It's pretty much the same as this other one in terms of that. There aren't any squares in this one, like you don't multiply it by itself in this one, unlike some of the upcoming ones, and there are no rational numbers except for the ones in here, but otherwise that's pretty much it. So I figured if I just showed the work I did, here we go, there's a rational number here, 4 times 3 is 12, so you put that on top of 2 and that divides it into 6, and then you get 3. And then over here you see there's a 3 minus 4 times 4x, and 4 times 4 is 16, so you get 16x, and then that's our answer, 3 minus 16x. Here we have 3 minus 4x times 4, so you use distributive property, same like over here, see where I use distributive property? It's pretty much the exact same thing. You say, okay, 12 and 16, and bam, there's 12 and 16. Then over here, you just multiply these two, and you get a positive. Crazy. Yeah, there's a positive right there. Or that's a negative.
but I think it happens in one of the other ones. Anyway, here we go. Yep, right here we graphed in the x minus 4, and we kind of go through and multiply those, and then put that in the equation, and then we get plus 16, which is 19. Sorry about the squiggles. Minus 4x. And then it gets more difficult past here, but this, like I said, it's pretty much similar to the other one. See, there's even the, like that, and that. But very similar. And I did the next one. So here's the ones with the squares. I did 9, 3 times itself is 9. And then it's, you know what's actually bugging me about this is the fact that I did, just wait a minute, okay, so the subtraction symbol is separate. It just kind of bugs me to see -3 times -3. It's a good thing I put these in parentheses, because -3 times -3 is positive 9. So it bugged me a little bit, but I see where I went, where I was okay. I was okay in there. Okay, then here, this becomes positive because it gets multiplied by itself. Negative times negative is positive, so it becomes positive 1. But then I don't see why. Okay, so that's why it's back to 1. So it's 2 minus 1, and then it's 1. Okay, I was like, why is it back to positive again? It's a negative right here. Silly me. Okay, sorry, I got a little confused, because when you square root a fraction, or when you square a fraction, it's like multiplying the fraction by itself. And I forgot how multiplying fractions by themselves works, but I remembered that if you multiply 2 by 2, you get 4, and 3 by 3, you get 9. So you get like 9/4, see 9 over 4. And that divides into 2.25, because I like using decimals. They're just a lot prettier. So I used 2 minus 2.5, which was easier for my brain to handle, and I ended up with 2.5, or 1/4, negative 1/4. Okay? Yeah. Anyway, yeah, I got a little confused at the beginning, but I just had to review how to multiply fractions. Okay. Right here, we have 4x times itself, which equals 16x, because it's 4 times x, so you say 4 is a separate thing, and x is a separate thing, and so they become their own thing over here. 2 minus that, okay? Over here, we do distributive property again. We say 2 times 4 is 8, and 4 times x to the second power is this. Yeah. This confused me for a little bit, because I was like, wait, we're multiplying it by that, so it should be like this. No, it's because this squared both of these numbers, because they were within the parentheses. They're separate from this command here. Okay? Yep. So, here we go. We go here, and that's how that goes. Okay, so I got confused. Must have gotten confused. This one I solved this one just fine. This one I got really crazy on, as you can tell. The x minus 4 one. This one is pretty simple, really easy to do, but this one I got confused. So I did this and then this, and I got confused, and I thought like you just go through and multiply them each by themselves, kind of like this is this kind of distributive property thing. But then I went, no, wait. That means we're multiplying 2 of these whole expressions by themselves. So I separated them, but it took me a little while. I was like, hey, what? And then 2 minus that, then you go over here, and I had some struggles with some stuff, but I finally, because I forgot this was negative, like back here, I'm like, can't possibly be negative. It looks, negative 4 times negative 4 is a positive number, because they're both negatives. And then I'm like, wait a minute. But anyway, according to the book, this is the right answer. But I'd like to disagree. I'd like to find out why that is, because like I said, that's not the same. You know what I mean? These are the same expression. -4 times -4 is -16, or positive 16. But -16 doesn't make sense to me. I don't know why. X times x. We're subtracting anyway. 2 minus x. Well, I guess that makes sense because we're going through and adding a subtraction symbol to all that. So now I see why that is. But previously I didn't see why that was. I was like, what? But now I see. That's why. Because, yeah. Okay. I got it. So 2 minus all the positive numbers. Or all the these. And that's why we have -4 at the end. Okay, never mind. Okay, we're going to solve the next one. On to the next one. It is 14, number 14, and it is of a similar, I want to say breed because it's silly, but it's of a similar family. Family's a good one. We got family. It is, well, it's harder, but it also includes a square in it. You know, there we go. Then we have f of 3 to start because there's f of 3. And we'll say equals 3 squared minus 3 times 3 plus 2. Okay. And in here, we'll say this is 9 minus 9 plus 2. Okay. Or 9 minus 9 plus 2. In this case, that means we just end up with 2. Because these kind of like tackle each other out and you only end up with 2. The next one will be f of -1. You get -1 to the second power minus 3 times -1 plus 2. Then you say -1 times -1 is 1, because it's a negative times a negative. And then we multiply this, so we say this is plus 3 now. This is plus 2. It's really simple math now. Really simple. And we end up with 1 plus 3 plus 2, which is 6. Just making sure I got that right. Okay, next one. F of 3 over 2 is equal to yeah, sorry, my brain blipped again. Here we go. Or, excuse me, 3 over 2. That's what we're replacing in here. That's how functions work. 3 over 2 squared minus 3 times 3 over 2 and plus 2. Okay. Right here, we're multiplying this by itself. Now when you multiply this by itself, I found out quickly, like what happened here, that it equals 9 over 4. So we're going to say 9 over 4 minus 9 over 2, because that's what happens when you got this, plus 2. Okay. And we're going to make these like. I'm not talking like a teenager, like we're going to make these like, so like, you know, like, but we're going to make them the same. We're going to make the denominators the same. Here we go, 9, 4 over like 18. That isn't 18 people, sorry. Here we go, plus 2. We say equals, okay. Then we're subtracting 18 from 9, so we get -9 sorry to be so negative, plus 2 equals 3 over, not, okay, there we go. And then technically we could say this is 8/4. Yeah, we could do that. Because that's 2 still, and it has the same denominator. But we are going to subtract this because this is a negative number. Well, I subtracted in my head, and then I reverse it to negative again. It's a weird thing my head does, but negative numbers are so hard for my brain to handle sometimes, so I do that instead. So we end up with -1/4. There we go. And looks like I have to go over to the next page, or to the next couple pages, because the next page has one of the problems already solved on it. Okay, so we're doing, I'm gonna write actually at the top here so I don't have to recheck all the time. -3x plus 2, okay. Yeah, we're doing 14, so we're good. Okay. I just did 3/2, so now we're going to do 4x. F of 4x equals 4x squared minus 3 times 4x plus 2. So here, I believe this has already happened. Let me think. Yeah. Yep. So pretty much what we're doing here is squaring the 4 and squaring the x, but you can't do anything with the x because, because it won't do anything. I don't know, it's just so mean. It's so stubborn. Such a stubborn x. Anyway, actually, it's more about possibility of what that x could be. It's quite full of potential. But anyway, 12x plus 2. And yeah, that's as far as I'm going to simplify that. And then, oh, we're back to the 4f ones. Woo. Okay, here we go. 4f of x is going to be equation up there. Good thing I put that there. X squared minus 3x plus 2. Man, that other dash is really taking me off. Okay, there we go. And here we end up with we get 4 times x squared times not 3. We get 12. Because 3 times 4 is 12. Yep. Then plus 8. So you get 12x plus 8. And yep, that's where I'm gonna go with that. And I'm adding this for audience pleasure, I guess. Man, I need a drink. Okay. This next one is f of negative x. I think this one's my favorite. Because it makes you just keep the whole thing the same. Except you do that. And that's pretty much it. Yep. Yeah, because, yep. So that's how that goes. Really interesting. Here's the f. Yeah, it only changes this one because of the, I'm still not entirely sure why it doesn't change this, but I'm pretty sure it doesn't change it because negative x times negative x is positive anyway. You know what I mean? So even if I were to change this into a negative, it wouldn't matter. It would be technically correct, but it wouldn't matter because it's the same as a positive times a positive. A negative times a negative still makes a positive, as does the positive. So it wouldn't be necessary for me to add a negative there, but I could theoretically, because that's how it works. Anyway, next one is hard one. X minus 4 equals, let's see, x minus 4. Oh no, we're squaring x minus 4 again. Ooh, okay. Minus 3 times x minus 4. We're making it special this time. Plus 2. Okay. So this is gonna be extra long. Here we go. I'm just gonna start all the way on the side of the page. Equals x minus 4 times x minus 4 minus 3x minus 4 plus 2. There we go. Okay, it didn't take up the whole page, but it was still pretty big. I mean, it had to double this in size. So then we can solve. Pretty easy. X times x is x squared. X times negative 4 is negative 4x. X times, 4, negative 4 times x is also negative 4x. And then negative 4 times negative 4 is positive 16. And that might be how it just goes for the rest of my life, is that it'll be like, anyway. We're still in problem 14, right? Oh, we're still in problem 14. Okay. This is pretty sure positive 16. And if somebody tells me otherwise, I'm going to be super frustrated, Okay. Negative 3x and then negative 3. Well, I'm not going to be super frustrated. I'll be plenty open to why. What the heck, Okay. Negative 3x, positive 16, negative 4x. Or actually, we're adding stuff up a little bit now, so I'm going to make this an 8. And then we're going to have that. And then we're going to have this. And that's equal to that. Okay. And we have even more to go. This will be 30. And this will be, I'm kind of like, this is your destiny. You have always been destined to be a 30. But here we go. X squared. This we get negative 11. Not a prime number. Anything but that. Because then I can't divide the freaking thing. Okay. And that solves our problem. Ta-da! Okay. Then we're going to have the homophone one, like where it sounds exactly the same. Fx minus 4. F of x minus 4. See, it sounds exactly the same. I mean, maybe I say it different, like, this one's f of x minus 4. And this one is x minus 4. But it doesn't matter. It still sounds roughly the same. Anyway, equals x squared. Where's the equation? There it is. Minus 3x plus 2. Yeah, plus 2. Okay. Then in this situation, we will and we subtract 4 from all of it at the end. And in that case, which is a lot easier actually, this really goes really fast. You could say the same thing, but this one is definitely harder. I mean, it just takes more work. It doesn't necessarily, it's not that hard. Minus 2. There you go. And then, last one. F of x squared equals x squared again by x squared. Minus 3 times x squared minus 2. Now this actually is really fun because this here is equal to 4. And I can explain. Here we go. We'll prove it. Here we go. So let's say this is a 3, okay? We say 3 times 3 is 9, right? 9. And then we say 9 times 9 is 81, right? 81, okay? Well, let's say we do this to the 4th power instead. Like we add these up and we say it's just this to the 4th power. Well, that would mean it's 3 times 3 times 3 times 3, okay? That would mean 3 times 3 is 9, times 3 is 27, times 3 is 81. Look the same? That is because they are the same. So pretty much what you do is you say, I mean, it's not the same, like, written, but that is why we do x to the 4th power instead of this weird parentheses thing, because it equals the same thing. And then we say 3 times x to the 2nd power, and then minus 2. Am I right? Am I wrong? Nope, I got it. I was double checking, make sure I got it. It helps me learn better if I just write it down and I don't do anything much with it. Okay, that was problem number 14. Now we go on to 16. Now, notice I've already done 15. Here we go, same. X over x minus 1. And the next one also includes a fractional expression. Rational expression, excuse me. So I'll even show you. It's f of x equals 2 over, excuse me, my throat's really doing terrible. Okay, over x to the 3rd power. Ooh, to the 3rd power. We're all gonna die. Okay, anyway, if that's the case, well, I'll show you my work on this one. So this one is a little simpler than the other one because it doesn't include this. But otherwise, it's pretty good. Here, let me just finish writing this one because we all know this. We all know how this is gonna go. See, right? And I showed you before on this magical page here that 3 times 3 times 3 is 27. So look what I did here. 3 times 3 times 3. So we did it to the 3rd power. So in that case, we get 2 over 27. And that is our answer. I'm just going to stick with it for now. But over here, we have these. So you get 3 over 2 over here, which is kind of funny because over here we have to use 3 over 2. And I got really confused. To be completely honest, I got kind of confused. But it's because I've never really divided fractions. It's like dividing by divisions, like dividing divisions. It's kind of meta, kind of within itself, sort of. Anyway, the deal is we're dividing divisions, which pretty much cancels itself and makes it multiplications, I'm assuming, from the top integers, the top numbers. So you multiply the top numbers and then you get that. Pretty sure. That's as far as I can explain it. That's what I'm pretty sure happens. But here, this is really easy to explain. Simple arithmetic, you know. But yeah. And then yeah, that has the same value either way, whether it's negative or positive. So here we have this 4x or 4x minus 1, and this is the answer. I put it in a box to be like, yeah, that's as far as I'm going to simplify it. Technically, I might even be able to omit the 4's, but I'm not sure. Because, let me test this over here. So this would equal, say if I plugged in 3, because 3 is a magical number. we get 12. Sorry, I'm making sure they're separate. 12 over 12 minus 1, which would equal 12 over 11. That cannot be simplified. Okay, well, what happens if I put 3 over 3 minus 1? You get 3 over 2. No, these are not the same. Okay, never mind. You can't simplify by canceling out the 4s. Dang it. Oh well. Life. That's how it goes. Anyway. Okay, we do this 4 times f. You just multiply the top one by 4, which is easy. It's just 4 of these. Excuse me, allergies. Okay, then here, that shouldn't take much to explain, but pretty much the absolute value for either one is the same. Excuse me. Okay, here we go. Right here. And then we have this. This is pretty easy because you subtract 1 from that and you get x minus 5. Over here, I like how simple this one is. After all those rational expressions, it's like, oh, phew. Anyway, here we go. Minus 4. And yeah, that one pretty much explains itself. You just put a minus 4 at the end there. Then over here is the next one. X squared, and then you get x squared over x squared minus 1. Okay, here we go, onward to the next one. F minus 1, f of negative 1, 2 equals 2 over negative 1 to the 3rd power. Now, I think that'll still be negative 1. I'm just going to make a guess here, but I'm pretty sure that is still negative 1. Because, well, yeah, because if this is negative, like, negative 1 times negative 1, right, is positive 1. But if you multiply it by another negative 1, you're going to get a negative 1, okay? Pretty much the general rule of thumb is if you're multiplying a negative number, or if you're doing a exponent from a negative number and it's a 3 or a 5, the general rule of thumb is it's still going to be negative. But if it's a 2 or a 4 or an even number, it's going to be a positive. At least I'm pretty sure. I don't know. You could get a really crazy number of exponents out there, but I'm pretty sure it's pretty consistent with the idea of being odd or even. Anyway, yeah, then we'd end up with equals 2 over negative 1. And then you'd end up with, because it's negative, you'd end up with negative 2 as your answer. This is a 1, not a parenthesis. Okay. F of, we're moving on now, we're to 3 over 2. And in this one, it's a little difficult. We're going to say 2 over 3 over 2. Dividing divisions again. Here we go. Over to the 3rd power. This is going to be a little epic. Definitely going to be epic. Okay. 3 times 3 times 3. 3 times 3 is 27, right? But we don't do that. We say 3, 2, 3 over 2, again by 3 over 2 later. This is 9 over 4 times 3, so this is 27 over 8. And then we're going to say 2 divided by that. which is the same as, well, okay, I know exactly what I did wrong. Now we have to divide it by this. So when you're dividing this, I know exactly what I'm doing, right? You divide it, or why did I multiply fractions like this? Okay, when you take this, you say 3 over 2 times 2 over 3. Then you get 6 over 6. No, that makes no sense. Because then you get 6 over 6, and then you have to multiply it. Well, let's see, 6 over 6, you have to multiply it by 3 over 2. And you'd get 18 over 12. Okay, I obviously don't know what I'm doing. Maybe we do it like this. We say 27 over 8. And then to multiply it by 2, we have to swap them or something. And then it's 16 over 27 because that's what the answer is. And I'm pretty sure that's how it goes. Or you could swap both of these and then they just be under it. Yeah, maybe that's how they did it. But that's the only way I can think of off the top of my head that they do that. By doing this thing over here. Yep, so that's crazy, it's a mess, but something in my head says, okay, that sounds about right. Anyway. Yeah, this one is the hardest one, and I don't know exactly what I'm doing throughout half of it, but here we go. 4x, then we say, 2 over 4x to the third power, okay? 4 times 4 is 16. Times 4 is it 64? Yeah, 4 times 4, 16. 16 times 4. Yeah, it is 64. We're good. Okay, so in that case, we'll say f of 4x is equal to 2 over 64 x to the third power. Okay, pretty simple, but we can simplify it further. I loved this in elementary school, doing this like 1 over, not 64, 32 x to the third power. Okay, super simple. Then next one, dang it, this video is taking way longer. Okay, f times or 4f, sorry, this is the 4f times x is equal to 24. The reason being, I wrote down the answer. Oh, yeah, that's the reason. No, but I can show you why I get that answer. The reason is because I go 2 over x to the third power. And no, this is not 24. No, this is not 24. I am so messed up. Okay, here we go. I know, the worldwide answer, everybody thinks the answer to everything is 42, but actually it's the inverse. It's 24. No. See, my brain just did this weird thing. Anyway, here we go. Yep, and then we multiply the whole thing by 4. And that way we get 2 times 4, which is 8 over that. which is the real answer. What? I still don't know why I did 24. Oh, 8 times 3. This is a bigger x, I swear. Okay, 8 times 3 is 24, so I messed up. Okay. F of x, or excuse me, negative x is equal to that. Oh, not 2. I keep doing that. Sorry. And here, or sorry, it's negative that because it's negative x. Then over here, we have f times x minus 4 equals 3 over x minus 4 to the third power, which is crazy. You know what I'd have to do to get the maybe, so like which one's simpler? I'd have to show you which one's simpler. And then even crazier. I mean, this is like this is not simpler. It is much longer. Then you have to then you go through and you use a distributive property, you do the more distributive property, and it's like, that's it. I'm crazy. I think this looks simpler. It also looks like I'm multiplying it by 3, but this is simpler. And then this one, we're almost there. Here's the homophone. 2 over x to the third power minus 4. If we want to go crazy, we could theoretically put 4, we could subtract, multiply it, subtract, all that. Anyway, it's kind of to explain, but here's the next one. Or, sorry, should I say the last? Haha, this video is almost over. Congratulations. Yeah, so this is a bit difficult. Here we go. I'm gonna say, well, no, this isn't difficult because we just say 3 times 2. Remember how we did 2 times 2? Somewhere around here. Yeah, I think it was this one. No, it was on the other page. But whatever we did, we took the numbers and we made them 2 times 2. We proved, see, we proved this. It's right here. That, not 2 times 2, but 2 times 2, you pretty much multiply the number of exponents you have. So over here, we say x times 6 because we get x's second power to the third power, which is 6, which makes sense. I could prove that too, but it would take a whole lot longer, and I'm pretty sure you're tired of watching this video. So thank you for watching.